Okay, front end's off, so two wings, so the bumper is off, even though it's kind of all one piece. That was probably not the way how to take it off, but again, never worked on one, so we're just kind of figuring it out as we go along.
Forget the instruction manuals and the golden rules of supercar repair. Because when Matt Armstrong laid his hands on that $4 million Bugatti Chiron Pur Sport, he didn't just break them, he tore them to shreds. No one believed a jigsaw and a welding torch could turn a supercar into a masterpiece, let alone push the legendary W16 engine beyond limits Bugatti itself never dared to imagine. The sheer audacity of this famous British automotive YouTuber even prompted Bugatti's CEO to immediately personally intervene. So, what exactly happened to Matt Armstrong and the written-off hypercar he was determined to bring back to life? A verdict from the manufacturer. The story began with a simple traffic accident that lasted only 3 seconds. Alex G., the owner of a Bugatti Chiron Pur Sport with chassis number 795276, one of only 60 Pur Sport models produced, collided with an Isuzu delivery truck in Miami in 2021. Although the impact was at a low speed and would have caused only minor damage to a regular car, this hypercar, built from carbon fiber and specialized alloys, suffered far more severe consequences. The collision shattered the front left fender and damaged the headlight and front bumper. More importantly, the force of the impact traveled deep into the vehicle's structure. The car was no longer drivable and was taken to a dealership for an assessment. Bugatti Automobiles SAS sent a team of technicians from France to Miami for an inspection. After several days of analyzing the carbon fiber monocoque chassis, they concluded the vehicle was a total loss. This decision was not solely due to the high replacement costs. Engineers were concerned that the core carbon fiber structure could have suffered microscopic cracks or weaknesses invisible to the naked eye. For a vehicle designed to operate safely at speeds over 420 kilometers per hour, 260 miles per hour, any compromise to its structural integrity was an unacceptable safety risk. Following this verdict, Bugatti took decisive action. The company placed the car's VIN on a global blacklist, effectively erasing its official existence. This meant Bugatti would not sell replacement parts for this chassis number, and authorized dealers were forbidden from performing repairs on it. The car was now untraceable within the official system. To support the decision, the insurance company received a repair quote from Bugatti with staggering component costs. $93,000 for the grille, $116,000 for a pair of headlights, $50,000 for the carbon fiber hood, and approximately $400,000 for the two front fenders. The total for just the exterior parts exceeded $1.7 million, not including labor or hidden mechanical damage. For Alex G., this became a financial burden. Although the car was written off by the manufacturer, he still had to make monthly payments of $90,000 for a $4 million asset that couldn't be driven, repaired, or touched by an official technician. Bugatti recommended the car be sold for scrap and dismantled to protect the brand's reputation. However, the car was not destroyed. Instead, the insurance company sold the wrecked vehicle at auction, where it was bought by a company specializing in damaged high-end cars. A new challenger arrives. The news of a blacklisted Bugatti Chiron Pur Sport spread through the niche community of salvaged supercar dealers and rebuilders. This information eventually reached Matt Armstrong, the creator of the popular YouTube channel B is for Build, where he documents the process of rebuilding crashed performance cars. He had previously worked on heavily damaged vehicles like a Lamborghini Huracan and a Ferrari 458, but this Bugatti was on an entirely different level. For Matt, Bugatti's blacklist was not an obstacle but a personal challenge. He saw an opportunity to attempt a project that no one had ever successfully completed before. In late 2022, Matt flew from his home in the United Kingdom to Miami to inspect the car in person. After a careful examination, he decided to purchase the vehicle and had it transported to a workshop he rented near Chicago. When the two halves of the Chiron arrived, Matt and his team began the long process of disassembling it further to understand the true extent of the damage. Free from the strict rules and procedures of Bugatti, they could investigate every single component. Their detailed inspection revealed that the low-speed collision had caused a far more serious internal problem. The force of the impact had pushed the entire engine and transmission assembly forward by just a few millimeters. This tiny, almost imperceptible shift had created immense stress on the points where the powertrain connected to the chassis. This stress resulted in a critical crack on one of the main aluminum engine mounts, which was bolted directly to the carbon fiber monocoque. This crack was the fatal flaw that Bugatti's engineers had identified. According to the manufacturer's standards, this cast aluminum part was unrepairable. The only official solution was to replace the entire rear subframe and possibly part of the monocoque itself, a job that would cost over $1 million and could only be performed at the factory in France. As Matt continued to take the car apart, he made another startling discovery. While examining smaller components like sensors, switches, and control modules, he began to notice that many of them were not unique to Bugatti. He found electrical connectors and electronic parts that were clearly marked with the logos of the Volkswagen Group. Some switches inside the car were identical to those found in much more common vehicles, such as Volkswagen Jetta diesel cars, while other parts were shared with various Audi and Bentley models. This practice of parts sharing is common in the automotive industry to reduce costs, but finding components from a $20,000 car inside a $4 million hypercar was a revelation. It exposed the reality of the hypercar tax, the massive price markup applied to standard parts once they are placed in a Bugatti box. The process felt like dissecting a mythical creature, only to find that its internal organs were the same as those of ordinary animals, achieving the impossible. In order to properly repair the cracked engine mount, Matt needed to do something that Bugatti claimed was impossible without its own specialized equipment. He had to completely separate the car into its two main sections. The Chiron is built with a modular design, where the front section is the carbon fiber passenger compartment, or monocoque, and the rear section is a massive subframe that holds the W16 engine, transmission, and rear suspension. Bugatti stated that only 2 facilities in the world had the multi-million-dollar alignment jig required to hold the 2 halves of the car in perfect alignment during separation and reassembly. Without this jig, they argued, it would be impossible to join the 2 halves with the sub-millimeter precision required for safety at high speeds. Matt Armstrong did not have this jig, so he developed a completely different method using the tools available in his workshop. He and his team placed the car on a standard 2-post automotive lift. They then positioned a large blue plastic trash can with wheels directly underneath the heavy rear engine assembly. They carefully stacked pieces of wood between the top of the trash can and the car's subframe, creating a simple but stable temporary support. The next step was to disconnect everything that connected the front and rear halves of the car. They discovered that the entire rear section was held to the front monocoque by just 14 large titanium bolts. After removing these bolts, they spent hours carefully disconnecting all the electrical wiring, coolant hoses, oil lines, and hydraulic systems. Once everything was disconnected, the moment of truth arrived. The team slowly raised the automotive lift. The front half of the Chiron, resting on the lift's arms, began to move upward, while the rear half, with its massive engine, remained stationary on top of the trash can. With the 2 sections completely apart, they gave the rear assembly a gentle push. The entire back half of the Bugatti Chiron Pur Sport rolled smoothly across the garage floor on the wheels of a plastic trash can. In an ordinary workshop using basic tools, Matt Armstrong had successfully performed a procedure that the manufacturer claimed was impossible without its exclusive technology. With the car separated, the team now had full access to the cracked aluminum engine mount. Instead of replacing it for an enormous sum, Matt sought out a local expert welder named Bob, who had extensive experience working with exotic metals. Bob examined the crack and identified the specific material as a high-strength aluminum alloy, likely A7 or I7, which is commonly used in the aerospace industry. He used a precise welding technique called TIG welding to carefully repair the crack. But he did not stop there. To ensure the repair was robust, he welded additional pieces of the same aluminum alloy, known as gussets, around the repaired area. These reinforcements would help distribute stress more evenly, making the engine mount even stronger than it was when it left the factory. A component that Bugatti had condemned as worthless was brought back to life and improved through human skill and ingenuity. A surprising intervention and a new identity. The rebuilding project, documented in great detail through a series of YouTube videos, became an internet sensation, attracting millions of viewers from around the world. The widespread attention eventually reached the highest levels of the automotive industry, landing on the desk of Matti Rimac, the CEO of the newly formed company Bugatti Rimac. Rimac, an automotive innovator himself, chose a very different approach from what one might expect from the head of a major corporation. Instead of sending a legal notice to stop the project, he sent a direct personal message to Matt Armstrong. The message was not a threat, but a professional conversation between two people who understood engineering. Rimac explained Bugatti's concerns from a physics perspective, pointing out that a 1,500 horsepower car generating immense forces at high speeds is more like an airplane on the ground than a typical car. He respectfully acknowledged Matt's skills, but also outlined the serious safety risks involved if the car's alignment was not perfect. This direct and respectful communication marked a major turning point in the project. Shortly after their exchange, Bugatti took the unprecedented step of removing the Chiron's VIN from its global blacklist. They even offered to provide Matt with technical data and critical safety-related parts to ensure the car was reassembled correctly. This was a quiet acknowledgement of the project's legitimacy and a huge victory for Matt. With this unofficial blessing from the CEO, Matt continued his work. But his goal was no longer simply to restore the car to its original condition. He wanted to give it a unique character. One of the common criticisms of the Bugatti Chiron is that its powerful W16 engine is relatively quiet and subdued, due to a heavy and restrictive exhaust system designed to meet global noise and emissions regulations. Matt decided it was time to unleash the true sound of the engine. He removed the entire factory exhaust system and partnered with a company called Valvetronic Designs to create a custom one. The new system was made entirely of lightweight titanium, featured a high-flow X-pipe design, and ended in 6 exhaust tips instead of the original 4. It had no mufflers to dampen the sound. The result was a dramatic transformation. The W16 engine now produced a loud, raw, and aggressive roar that was completely different from the refined sound of a factory Chiron. For the first time, people could hear the untamed sound of all 16 cylinders. This was more than just a mechanical upgrade. It was a statement of philosophy. Bugatti had engineered a car that balanced extreme performance with ultimate luxury and refinement. Matt had stripped away the refinement to focus purely on the extreme performance. The project was no longer just about fixing a car. It had become a contest between two ideals, one that valued controlled, distant perfection, and one that celebrated a hands-on human connection to the machine, a symbol for the right to repair. During the final stages of reassembling the car, a small and unexpected incident occurred that carried immense symbolic weight. While tightening one of the 14 main titanium bolts that connect the two halves of the vehicle, the bolt suddenly snapped. According to Bugatti's official procedure, Matt would have had to order a new proprietary bolt directly from the company, a process that could take weeks and cost a significant amount of money for a single piece of hardware. Instead, Matt turned to the internet. He researched the technical specifications of the bolt, including its size, thread pitch, and the specific grade of titanium required for its strength. He found an industrial supplier that sold a bolt with the exact same specifications. He ordered it online for $11. A few days later, the $11 bolt arrived, and it fit perfectly. It was tightened to the correct torque specification and performed its job flawlessly. This small event became one of the most powerful moments of the entire project. An $11 bolt, available to anyone online, had replaced an exclusive and expensive part on a $4 million hypercar. It served as a powerful symbol, representing a direct challenge to the idea that complex products can only be repaired with expensive, proprietary parts from the original manufacturer. This single action highlighted the core message of the entire endeavor, that even the most advanced and expensive machines are still just assemblies of physical parts that obey the laws of physics. It was a clear demonstration for the right to repair movement, which argues that consumers should have the right to fix the products they own. Bugatti's blacklist system acted as a digital kill switch, giving them the power to decide if a car lives or dies. Matt proved that with knowledge and skill, human hands could override that switch. A legacy of change. The completed Chiron project created a significant divide within the global car community, leading to the formation of two distinct camps with strong opinions. The traditionalist camp, which included Bugatti collectors, factory engineers, and automotive purists, argued that Matt's work had compromised the car's integrity and destroyed its value as a collector's item. They expressed serious concerns about the safety of a vehicle that was repaired outside of the manufacturer's controlled environment, questioning if it could ever be truly safe at its top speed. For them, the value of a Bugatti lies in its originality, its history, and the official certification from the factory. On the other side were Matt's supporters, a massive group that included his millions of YouTube followers, independent mechanics, and advocates for the right to repair movement. They saw Matt as a hero who had the courage to stand up to a corporate giant. They celebrated his ingenuity, his problem-solving skills, and his determination. In their view, the rebuilt Chiron was now more valuable than a standard one because it carried an incredible story of persistence and the triumph of an individual over a restrictive system. This debate was not confined to online forums. It had a real-world impact. Many believe that the project influenced Bugatti's future direction under Matt Armstrong's leadership. The successor to the Chiron, the Bugatti Tourbillon, was later unveiled with a naturally aspirated V16 engine and a complex analog instrument cluster crafted by Swiss watchmakers. This design was seen as a deliberate move toward a more mechanical and emotional driving experience, an acknowledgement that the value of a hypercar lies not just in raw numbers, but in the physical connection between the driver and the machine. The very connection that Matt's project had celebrated. The story of Chiron number 795276 ultimately raises fundamental questions about ownership and technology in the modern world. If you pay millions of dollars for a product, should the manufacturer have the final say in how you are allowed to repair it? Where should the line be drawn between manufacturer-guaranteed safety and the owner's freedom? The answers to these questions will continue to shape the future of the automotive industry and our relationship with the increasingly complex products we use every day.